Okay, now we're going to do this again, and by this point, some of you are thinking, in what world would anybody need to figure this out? You will see here in a moment. Okay, you don't want to write a check your butt can't cash, because you're going to see later on how this stuff is actually used in real life. Okay, first we need to practice the skills for doing it. Okay, so we want to add these fractions together. Okay. So the first thing I want to do is I can't just combine it on the spot like I can with multiplication. So I need to set up the big fractions, find an LCD, and then I can combine it into one. Okay? Okay. All right, so first I parenthesize. Now the only thing that would be parenthesized is this. Okay? So I have a 1. A 3x squared. I know I'm going to have those because those are all non-factorable. There's no plus, there's no minus. There's no way you can factor that. Okay, 9x to the power of 2 minus 12x. Okay, so GCF, and then we check for difference of perfect squares. Okay, GCF is 3x. So then I divide by 3x. And that's going to be 3x minus 4, which is not a dot, so we can forget it. So this expression is replaced with 3x times parentheses 3x minus 4. Okay, LCD, it's all about the bottom. So I have 3x minus 4. That's your only parentheses you have. Now look at stuff that's not in parentheses. What big number do you have not in parentheses? You have 3. You have it twice. That's actually good that it's there twice, but you have it. Okay, and then we have x's that are not in parentheses. Those are called our outside x's, outer x's. Okay, now for 3x minus 4, I have 0 of those, and I have 1. So I need to make sure that, or 1, got to make sure that gets a 3x minus 4. And the top also needs to get it if you're bringing it into the denominator. The numerator also gets it. Okay, outside 3's. Remember that ones inside the parentheses don't count. So that has 1 and that has 1. We're good on that one. Okay, outside x's. They can't be in parentheses. So that's outside of parentheses. That means there's 2 of them here. And that's outside of parentheses, but there's only one of them because it's just x. So what I can do here is simply take the one that had 1, just put that one to the second, and then just times by another x up here. You could also just put that to the second. It's fine. Okay, so now I'm going to combine the fractions now that their bottoms match up. So I circled just one of the bottoms. So we're going to write 3x to the second times 3x minus 4. Okay, and then I write what's on top. So 1 times parentheses 3x minus 4 plus x times x. Okay? All right, now, remember, you can dial up your Math Papa algebra calculator. If you want to Google that. Again, I'm going to show you how to do this on the scratch paper to simplify the top. That's what we're going to try to do next. And then we're going to try to factor whatever we get after we simplify it. Okay, so I've got 1 times 3x minus 4 plus, you want to circle the plus sign, and then x times x. Okay, so you got to find this product and this product. So you're going to have 1 times 3x and 1 times negative 4. That's just going to be 3x minus 4. Plus, and then x times x is x to the second, okay? Okay, so you'd have your 1x to the second, because there are no like terms, plus 3x minus 4. Okay, let's see if Math Papa agrees with my answer here, okay? So I had 1 parentheses. You don't need to hit your times. You can just go to the parentheses. 3x minus 4 plus x times, to go do times, you go shift 8, okay, and then x. Okay, let's see if they agree. Yep, x is second plus 3x minus 4. Okay, so we did that one right. You find this product, combine your like terms. Okay, so the top is simplified. 1x squared plus 3x minus 4, and I'll be using the Math Papa calculator for the rest of them so it doesn't take longer than it needs to. So we factor the top. It's a trinomial, so GCF, and then I check and see if my t-chart works. Okay, so GCF, we do not have one. 1 times negative 4 is negative 4, difference of 3. Okay, that's 1 and 4. Okay, A equals 1 here, so I just need 2 parentheses. So XX, 1, 4, and then you got plus 3x. You're going to have plus 4 for sure and minus 1. Okay. Okay, so I make my top and I just drop my denominator down there. So 3x is second times 3x minus 4. And remember, this turned into this, which turned into that. So it's x minus 1 times x plus 4. And are any of the parentheses factors identical? They are not, so that is my product. Okay. Okay, my next one. Again, we want to parenthesize where we have plus and minus, okay? Okay, then I want to combine it into 1, but I can't do that until I extend the fractions, come up with an LCD denominator, and after that, then we can combine, okay? Okay, so x plus 3, pretty sure that can't factor. Okay, I mean, let's be honest, there's no GCF, it's not a DOP, so we're just going to put x plus 3. Okay, I would hope the bottom would be factorable. Okay, so 1x squared minus 2x minus 8. Okay, so GCF, and then the t-chart, okay? GCF, I don't have one. Then 1 times negative 8 is negative 8. I'm looking for a difference that would equal 2. Okay, so 1, 8, no, 2 and 4, boom. Okay, and A equals 1. So I've got minus 2, and difference is plus 2. So x plus 2 times x minus 4. Okay, x minus 5 I'm pretty sure is a prime expression, meaning it can't be broken down. Okay, x is second minus 12x plus 32. Okay, GCF, and then the t-chart. GCF, you don't have one. So positive 32, looking for a sum of 12, and that's 4 times 8. Okay, so A equals 1. And then 4 and 8, so we got minus 12, so minus 8 and minus 4, okay? So that becomes x minus 4 times x minus 8, okay? All right, so LCD. You've got a factor of x plus 2. You've got a factor of x minus 4. You got an x minus 4, but I already wrote that, and then x minus 8, okay? X plus 2, I'm 1 and 0, so I need to bring an x plus 2 to that one, and we got to times the top. Okay, x minus 4, I got 1 to 1, good. X minus 8, I got 0 to 1. Okay, so x minus 8, x minus 8. Okay, so we can combine those. Remember, when you're adding, you just combine it into 1. So I only take one of the denominators because they're exactly the same. X plus 2 times x minus 4 times x minus 8. Okay, then I need to write x plus 3 times x minus 8 minus, I keep that circled, and then x minus 5 times x plus 2. Okay. All right, now we need to simplify the top, okay? Now, here's what some people will do. They'll get there and they'll start crossing off. No, don't cross off. You can't cross off with that minus sign right there, okay? It has to be all multiplication outside, and it's not, okay? So you should, a lot of people see x plus 2, let's just cancel it right there. You can't, okay? Not with that minus sign outside. You need to get rid of that somehow. Okay, so I'm going to be taking my algebra calculator on Math Papa and taking x plus 3 times x minus 8, and then I hit minus, and x minus 5, and x plus 2, okay? Calculate it. Okay, negative 2x minus 14, okay? So there's my simplified top. And if I were to FOIL that and then collect like terms, I would hope that's what I'd get, okay? I would, if I did it correctly. But it's easy to make little mistakes on this. It's easier to, because eventually we're going to get to things where you have to be very precise, so it's easier if we just use this to avoid people getting bogged down with the mistakes. So GCF and DOPS. GCF, you got negative 2, okay? So negative 2 pulls out, and then we divide by negative 2, and that's going to be x plus 7. Okay, not a DOPS, clearly. So, put your denominator, x plus 2 times x minus 4 times x minus 8. And then I put that on top, because that's what I ended with. Negative 2 times x plus 7. Okay? Can't, nothing cancels. That's your difference. Okay, my next one, 5 over x, so parentheses there and there. Okay, it's very important we parenthesize those. 5 drops, 35 drops, and x plus 2 is a prime expression. I mean, there's two terms, but there's no way that we are going to be able to factor that. So x a second minus 3x minus 10. Okay, so GCF, doesn't appear I have one. Okay. Okay, T that. Okay, so negative 10, difference of 3. That's 2 times 5. Okay, so A equals 1 here, so we can make 2 parentheses, XX, and it's 2 and 5. So our 3 is minus, it's minus 5 plus 2, okay? So I've got x plus 2 times x minus 5. Okay, so your LCD is pretty quick. It's all parentheses factors, so I have x plus 2, and then another x plus 2, and then x minus 5. Okay, now with that done, x plus 2, I'm at 1 and 1, so we're good. X minus 5, I'm at 0 and 1. So that's going to be times x minus 5 times x minus 5. Okay, now we're ready to combine it into 1. So I've got x plus 2 times x minus 5. Okay, now I write 5 times, and then x minus 5 plus the 35. Now, a lot of you could do that in your head. You know you're going to have 5x minus 25, and then plus 35. It's 5x plus 10, okay? So 5, let's see, check our answer on my calculator. X minus 5 plus 35, yep, 5x plus 10. Okay, so 5x plus 10 is my top, okay? So I want to see if my top will factor. So GCF and the T-chart, or no, DOPS. GCF is 5, just 5 though, not 5x, so then we go divide by 5, and that becomes 1x plus 2. Not a DOPS, so okay, so this is my denominator. So x plus 2 times x minus 5. Now the numerator, this became this, which became this. Okay, so 5 times 1x plus 2. Now this is why you need to factor the top, because you see these parentheses here, they match. So those cancel, and the answer is 5 over x minus 5. That's why it's important to factor the top if you want to get it into simplest terms. Okay, my next one. That is not a factorable expression because there's an absence of a plus or a minus. Okay, 5x drops down. Okay, x plus 2, and that'll just drop. Okay, prime. Okay, x is second plus 4x plus 3. I'm hoping that that's going to cancel, or that's going to factor, sorry. GCF and T. Don't have the GCF and the T. 1 times 3 is positive 3, sum of 4. Okay, it's 1 and 3. So A equals 1. So I just need 2 of them. So XX, 1, 3. So I've got plus 4, so you're going to have plus 3 for sure and plus 1. So X plus 1, X plus 3. Okay, that is adopts. There's no GCF to it, but it's definitely adopts. You got a difference in X times X and 3 times 3. Okay, LCD. Well, I've got X plus 1 as a denominator factor. I've got X plus 3 as a denominating factor. Another X plus 3 and then X minus 3. So X plus 1, I'm 1 and 0. So I need to make sure this gets an X plus 1. Okay, X plus 3, I'm 1 to 1, so I'm good. X minus 3, I'm at 0 and 1. Okay, so the 0 I times by X minus 3 times X minus 3. Okay. All right, here's my common denominator now. So I've got X minus 3 times X plus 1 times X plus 3. Okay. Now I'm going to type that in, see what the calc. By the way, some of you, again, you'd FOIL, you'd multiply, then you'd combine like terms. But you would switch at the plus, and everything I get over here would switch. But this one, sure, it will guard against careless mistakes that will wreck the problems that we're going to be doing. Okay, next. So it just helps you a lot if you do this. Okay. I mean, I'm on my last problem in this video. It usually, before I found this little tool, it would take like a video, just explaining a video takes like 35 minutes. Okay. And we're at 17:30 now. So negative 4x squared minus 6x minus 6. Okay. Okay, now, or shoot, sorry, what I should have done is just wrote all that. So x minus 3, got ahead of myself. Minus, circle it, and then 5x times x plus 1, okay? And then that on top equaled the negative 4x squared minus 6x minus 6. Okay, so that's 3 terms. And then the t-chart. Okay, so I have a negative in the front, and these can all divide by 2. So negative 2 pops out, and then I divide them by negative 2, and that becomes positive 2x squared plus 3x plus 3. Okay, ABC, that's positive 6, sum of 3. That's 7. That's 5, and that's it. Okay, so I'm just going to write fail. So that means I just go with this. Okay, so my denominator's here. So I've got x minus 3 times x plus 1 times x plus 3. Okay, and that stays negative 2, 2x squared plus 3x plus 3. Okay, and obviously none of the parentheses cancel. That's my answer. Okay. I'm going to help you out on this first one, get started, and you will finish it, okay? So this is the only thing that could possibly be factored. 7 and 9x squared drop. The x drops. And I should probably factor that bottom. So GCF and DOPS. Some of you are like, well, I'm getting good at this without showing the boxes. Fine, whatever. So it's going to be 1x plus 1, not adopts, okay? Okay, LCD. So we have a factor with 1x plus 1. Now you got a lot of outside stuff. You have a 9. You have a 3. And you also have outer x's, okay? Okay, so x plus 1, 0 and 1. So you need to bring the 1x plus 1 in there. Okay, 9, I got 1 and 0. So I should probably bring in a 9. 3, outside I got none and 1. So times 3. And times 3. Yeah, it's a good thing I'm setting this up for you. Okay. And then the outer x's. Well, I have, remember, that doesn't count. It's inside. Listen. Okay, that's 2 of them. And that's 1. Okay. So where there's 1, I can just make it to the second and times by another x. Okay. Now, as you can see, you want to clean up the crap outside in your denominator. So I'm going to keep the 1x plus 1 the way it is, but I should probably take 3 times 9 to get 27x squared. Okay. All right, now I have 7 times 1x plus 1 times 3 plus x times 9 times x. Okay. So let's see what they say. 7, and then 1x okay, times is shift 8, 3, okay, plus, and then x times 9 times x, okay? And what's going to happen is they'll take 7x plus 7, and then we'll times both those by 3, which would be 21x plus 21, and then that's going to be 9x squared, okay? So I'm expecting 9x squared plus 21x plus 21. Booyah, okay? Okay, now factor that. GCF. And then the T. Okay. GCF is 3. So 3x squared plus 7x plus 7. That's 21. Okay. Sum of 7 is impossible, so that's just what we'll have. Okay. So there's your denominator. You had 27x squared times 1x plus 1. And then you have 3 times 3x squared plus 7x plus 7. Now, outside factors here, obviously your parentheses won't cancel. But 3 and 27 can be divided by 3, okay? Because that becomes 1, which means I don't need it, and that becomes 9, okay? So try to cancel the outsides if you can. Okay, that's all I have to say on that. You go ahead and work. The rest should be pretty doable.